right, let's take a look at solving exercise 61 from section 3.5. We want to use the 7-step method to graph f of x equals 6x squared over x squared minus 4. First, we want to determine if there's any symmetry for this function. So we do that by evaluating f of negative x. So that means we go into the function, and wherever we see an x, we're going to put a negative x instead. Now, when we square negative x, that's the same as negative x times negative x, which is positive x squared. And we notice that this is f of x. So whenever our function comes back to us exactly as the original function, when we replace x with negative x, we know that the graph is symmetric with respect to the x-axis. Part 2 of the problem asks us to find the y-intercept. So in part 2, we're finding the y-intercept. And notice we find that by letting x equal to 0. So I go to the function. Wherever I have an x, I'm going to put a 0 instead. And I see I get 6 times 0 over 0 minus 4, which is 0 over negative 4, which is 0. So the y-intercept is 0. And that actually tells me that the x-intercept is 2. The x-intercept occurs when y is 0. Well, that automatically happened here. So notice my y-intercept is equal to 0. And then I kind of got for free that my x-intercept is 0. So I would put those into my math lab. So notice the y-intercept is 0 and the x-intercept is 0. So I put that information into my math lab. Now in part 4, I'm being asked to find the vertical asymptotes. So notice the first thing I do when I'm on my search for vertical asymptotes is I try to find the values that make my denominator 0. Now, just because a value makes the denominator 0 doesn't mean it's a vertical asymptote. But in order to be a vertical asymptote, you have to make the denominator 0. So I set the denominator x squared minus 4 equal to 0. I'm going to use the square root property here. So x squared is 4. That means x is plus or minus the square root of 4, which means x is plus or minus 2. So those are my vertical asymptotes, x equal 2, negative 2, and x equal to 2. Those are my vertical asymptotes. I'll use VA as an abbreviation. So I put that information into my math lab. X equals negative 2, comma 2. I'm separating my answers with a comma since there is more than one vertical asymptote. Now I'm being asked to find the horizontal asymptote. So let's take a look at that. Now when I want to find a horizontal asymptote, I'm looking at the degree of the numerator and the degree of the denominator of the rational function. So remember, my function is 6x squared over x squared minus 4. So notice the degree of the numerator is 2, and the degree of the denominator is 2. So whenever the degrees are the same, that means y equal to the leading coefficient of the numerator divided by the leading coefficient of the denominator is the equation of my horizontal asymptote. So the leading coefficient of the numerator is 6. That's the coefficient of the term with the highest degree. And the leading coefficient of the denominator is 1, because x squared is really a 1x squared. I have to think of that as a 1x squared. So there's an unwritten 1 here. That's my leading term. That's my term with highest degree. So y equals 6 is my horizontal asymptote. So I put that information into my math lab. Then I'm asked to plot points between and beyond the x-intercept and the vertical asymptotes, and I type the y-coordinate for each of the following. So my math lab has given me a table and wants me to complete the table. That's part 6. So I notice that I have the following information. My x-intercept is 0. My vertical asymptote is 2, and my other vertical asymptote is negative 2. So I want to pick values in between these, and the table has chosen negative 1/2. And also negative 3. You want something beyond the asymptotes. And negative 4. Those have also been chosen. By my math lab as some values. And these values are actually going to allow me to plot some points. And also 3 was chosen and 4. Typically, you want to choose a value in between the asymptotes and the intercepts and beyond the asymptotes. And since this function is even, it's going to be really easy for me to calculate this. I'm going to use the symmetry in this calculation. All right, so part 6 is telling me to let x equal to -4 in the function. So wherever I have an x, replace that with -4. And evaluate, find the value of this. So this is 6 times 16 divided by 16 minus 4. So 96 divided by 12, which is 8. Now, because this function is even, f of 4 is also going to be 8. And I get that just by symmetry. I can do the calculation, but I can, if I use the knowledge of symmetry, it saves me time. And then f of -3 is going to be the result of replacing all of the x's with -3. So I have 6 times 9 over 9 minus 4, or 54 over 5. And because of symmetry, that's also going to be what I get when x is 3. So I can go into my math lab and I can plug these values in for 3 and -3, 54 over 5. And then I simply need to find f of -1/2. And I replace each x with -1/2. All right, and in order to do this in the numerator, 6 times 1/4 is the same as 6 over 1 times 1 over 4. And in the denominator, I need to think of this as 1 over 4 minus, notice how I'm going to change the 4 to a fraction that has a denominator of 4. So I change 4 to 4 over 1, and I multiply it by 4 over 4, so I have a common denominator. So I have 6 over 4 over 1 over 4 minus 16 over 4, which is -15 over 4. And this is really a division problem. 6 over 4 divided by -15 over 4, which I can change to multiplication. 6 over 4 times -4 over 15. Which is -6 over 15. And I can divide top and bottom by the biggest factor they have in common, which is 3. So -6 divided by 3 is -2. And 15 divided by 3 is 5. So the answer here is -2/5. And I can put that information in my math lab. And when I do, I complete the table with these values. All right, now I want to use this information to choose the graph. So I'm going to do a rough drawing of this. Now here I've put in the asymptotes. So there's my vertical asymptote of x equal -2. Here's my vertical asymptote x equal 2. Here's my horizontal asymptote y equals 6. Okay, I'll zoom out a little bit on this. All right. And I have the x, y intercept. This was both my x-intercept and my y-intercept of 0, 0. And then I have those points that I got in the table. So if I think about these points, I have one of my points is the point -4, -8. I mean positive 8. That's not negative. This was a positive 8. -4, positive 8. So that was one of my points. So I go to x equal -4, and I plot positive 8. There's 6, 7, 8. Now when x was -3, I got 54 over 5. So here's x equal -3. And 54 over 5 is a little under 11. It's 10 4/5. So here's 6, 7, 8, 9, 10, and I'm right under 11 there. Okay, so similarly, I have 4, 8. So here's 2, 3, x is 4 and y is 8. And I have -3, 54 over 5. Remember, that's 10 4/5. So here's +3. And there's 6, 7, 8, 9, 10. And I'm right under 11. So it turns out that I'm going to approach these asymptotes and that's the picture I get on that for that branch. So the asymptotes are guiding me, as well as these points that I found by completing the table. They're guiding me also. And then remember, when x was -1/2, I got a -2/5, which would be somewhere in here. Now these points, and then because of the symmetry, I'm going to get the mirror image of that point on the other side of the y-axis. And again, the asymptotes are going to guide me, as well as these 3 points, the x-intercept, which is also the y-intercept, and these points when x is -1/2 and 1/2. And that value came from the table. So one branch is going to look like this. And this is rough. I'm having a hard time keeping the electronic pen straight, but that would be a smooth curve. It wouldn't have those wiggles in it. And I'll zoom out a little bit. So that's what the graph of this, it's going to look something like this. So let's go to my math lab and let's pick the graph that most closely resembles that. And we'll notice here that it's this third graph, not the first one or the second one, but the third one. So that's the one I selected. And we were able to use all of the information to get that picture.